folks, welcome back to Indaba Africa. This is Chris once again. Hey folks, welcome back to Chris White Africa here on the Indaba Africa channel, part of the Indaba Broadcasting Network. A lot of Indabas in there. Hopefully we decide something useful out of all those consultations and meetings. Welcome everybody. Joking Atheist says, going to bed. Who's going to bed? Anyway, StarCraft. I love StarCraft. Welcome back, folks. We are anxiously awaiting. We are now just minutes away from the Mars Perseverance rover beginning its descent. It's 7 minutes of hell from the atmosphere, or above the atmosphere of Mars, down to the surface of Mars, headed for the Jezero crater, the $2.7 billion exploration mission. We are ready, folks. Just minutes away. 3 minutes from now, the Mars Perseverance rover will begin its descent through the thin Martian atmosphere, headed for the Jezero crater, and we won't even see it. Why? Because it's too far away. Hello to everybody, and welcome for those who tuned in. Appreciate it. For the approximately half the audience that we kept from the last stream, thanks for coming over with us. Those who are new, thanks for popping in. Frank Cloy, you and me both. What are you talking about? Live chat. I missed something. Anyway, well, thanks for joining us, folks. Now, no need to panic. Relax, calm down, because we're okay. Because what's happening right now is that Perseverance will begin its descent in 3 minutes, but we won't even know it's begun its descent until 12 minutes after that. So that won't be till the top of the hour, which is approximately 18 minutes from now. And then we'll find out. Is that right? Did I do my math right? No, not 3 minutes. It's in 6 minutes. Right? Huh? 6 minutes, not 3 minutes. My bad. Bad math there. Oh, failure. I must be using Common Core or ANC matrix standards. I can't count the time. I'm sorry, folks. We are 5 minutes away from the Perseverance beginning its descent through the thin Martian atmosphere, the descent down to the surface of Mars. Fingers crossed, ladies and gentlemen. Fingers crossed. Frank Cloy, Mr. Punisher, Jake Ellis, Brandon, Amy, Justine LaRue, Bav Z307, Rebellious Ruth, Mr. Savage, Brandon, Dietrich Busha, Cameron Heslop is here, Johan Badenhorst, Malcolm Stark, Lezan is back, Nico Nell, Erica, Bosch Zebra, MF, Nick Muller. Wow, everybody's chatting. Leanne Prentice. Am I missing? And I'm catching up in the chat now. The Mountain Goat. Okay. That should be interesting to see what happens there. Mods, keep your eyes open. Hank Adrian Zay. Ants42, Bram Janssen von Rensburg, Garth McCarthy. Carl's back once again. Lazon. Beth Frazier's here. Blake says hi. Second grader watching with me. Cool. Hello, Blake. Thanks for joining us. I hope you guys are enjoying it. We are going to switch over to NASA's coverage here just in a few minutes. And then I will provide some commentary during NASA's stream. Sounds like Malema, Pinocchio, and the Key. Hopefully no boom. No. Well, if there's a boom shakalaka, we won't see it because it's a long ways off. Marnus Hayden says you can do it. You can do it. Let's see. All right, folks, we are now just 4 minutes from the descent beginning. You won't see it in 4 minutes, and you won't see it until the top of the hour. Hopefully, the telemetry data and the information will start coming in at that time frame. Right. Barbara Schillingall is back again. Welcome you once again. $2.7 billion car-size Mars rover, Perseverance. 85% of this particular rover is existing content from the previous missions dating back to 1997. Of course, we had the Viking landers there back in the 1970s, 76, and then nothing again until 97, 21 years later. Since then, this is the fifth attempt to land Martian rovers. The Perseverance is a unique one. It has all kinds of capabilities that the previous mission did not have, including ground-based radar. It can ground-penetrating radar. It can go 10 meters deep below the Martian surface or 33 feet, looking for signs of ancient life. Pretty cool. Also has a few other little toys on it. I'm trying to find those toys. It has X-ray spectrometer on it and an ultraviolet laser. How cool is that? As Dr. Evil would say, can I get some frickin' sharks in here with ultraviolet lasers on them? Malcolm says he'll watch tomorrow. All right, Malcolm, sorry you got to drop off. I hope you're well rested. Garrett says, yeah, what better way to spend my time but listening to you while I prep for my D&D stream? D&D? Ooh, you've got streams too. Wow. NASA has 1.7 million people watching their stream. Yep, that's pretty impressive. People love this stuff, folks. I mean, when we watch SpaceX streams, it's pretty amazing. That's some pretty cool stuff. Brett says you are delaying my streaming, space nerd. Just kidding. Your aunt called. Oh, okay. And Nick Muller just gave 70 Rand through the super chat. And what did he say? Thanks for making the stream. Thanks for the stream, Colonel. History in the making. It is. It is. Nick Muller, you're absolutely right. This is history in the making. Folks, we are 2 minutes and counting from the Mars Perseverance rover beginning its descent through the Martian atmosphere down to the surface. 7 minutes of hell. 7 minutes of hell. Cool beans. How cool is that? Yep. What else? So they're going to map the surface with this. They're going to use the ground penetrating radar to go through layers of rocks and sand, and ice, looking for signs of life, ancient life. Wow. This is so cool. So cool. Lars Salas has a good question for Garth. Do you play live or do you stream about D&D? Be pretty cool. I haven't played D&D in a long time. Back in college the last time I played. Yep. And this mission is different because the Perseverance is designed to collect samples, and then those samples are intended to come back to planet Earth, the big blue marble, by 2031 at the latest, a joint venture between the European Space Agency and NASA. Well, 1 minute before it goes, before I do, folks, I don't have a JPL shirt, and I don't have a Houston shirt, but I have been to the Kennedy Space Center, and I am wearing my Kennedy Space Center, which is a year older than I am. I am wearing my Kennedy Space Center shirt in honor of NASA's mission. We are waiting. It is now time for Perseverance to go down. Well, let me switch over to NASA. You're not going to see anything, but let me just switch over anyway. And then I'm going to take myself off the screen and start doing things a little bit differently here. We'll pick up the NASA feed and carry it the rest of the way, folks. All right, you ready for that? Let me go ahead and shut down my screen. I'll still be here.
Seconds from entry interface.
10, 9,
5.3
8, 7, 6, 5, 4, 3, 2, 1. Atmospheric entry. Here's the animation, folks.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
120 kilometers above the surface currently.
The spacecraft is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target.
Controlling its attitude.
Has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
Double mask. Oh, gosh. How cool is this as species, folks, that we do this stuff?
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Fingers crossed, folks. 3 minutes into descent, 4 minutes to go. 10 G's, that's brutal. That'll make you black out.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
You're 2 minutes from landing, folks. Parachute has deployed. Only in America.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
It's going to come down quick now. No, Zed, it's not supposed to land for 2 minutes. No, Eric, it's been traveling since July 30th of last year.
Yes.
Good news.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface.
Hitting all the
Perseverance
checks.
is continuing to descend on the parachute. We are coming up on the initialization.
1 minute
of
from
navigation
touchdown.
And subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers. We have confirmation that the lander vision system has produced a valid solution.
Yes.
As part of terrain relative navigation.
Awesome.
We have priming of the landing engines.
Priming of the engines. We're less than a minute from touchdown.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars.
Ah.
Confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
She's doing a great job narrating this. She's doing a great job.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
So close, folks. Fingers crossed. We are in the final minute. Seconds away from touchdown to surface of
We
Mars.
have started our constant velocity accordion, which means we are conducting the sky crane
Maneuver.
The sky crane maneuver.
Sky crane maneuver coming up.
Tones.
As expected. As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
It should be on the ground.
Touchdown confirmed. Perseverance
There it is.
safely on the surface of Mars, ready to begin seeking the sands of past life.
Now, I don't mean to bust everybody's bubble, and they're all excited and everything, but the data takes 12 minutes to get back, so this is simulated. Their joy may not be simulated, but the rover, we don't know that it's landed yet. We hope that it's landed. We won't know for another 3 or 4 minutes whether the actual descent began the way they've just played it out. So congratulations to NASA, but until 1607, I'm not going to pop that cork on the champagne bottle because it hasn't really happened, at least for us. It's happened on Mars, but the data's not here yet, so pretty funny stuff. So anyway, hang in there, folks.
We got it.
Touchdown confirmed. We're going to wait for the images.
Yeah, I got to wait for the images.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
Well, we are staying tuned for the pictures. All right, we're 3 minutes from the first data that should be arriving back from telemetry on the descent.
So much has been riding on this.
Schrodinger's rover.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight, we've seen the completion of EDL 3000. Copy activity. That is as expected.
I thought there weren't any women in science. That room is full of women. Or are they just a bunch of dudes dressed up as women? Remember? STEM? Women are never in science?
Seeing a strong signal from the lander.
What a load of crap. Oh, we got a signal. There it is. Still 2 minutes ago. They're gender fluid, says Amy.
We've just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Of course, that's an image from space.
This is OL3.
Is that the best they can do, that tiny little screen image up there?
Point on the map when you are ready. We are ready, OL3. Go for it.
If you only see 3 women, Cameron, you're not looking very hard. See, that's the image right there above the Mars 2020. And that's from orbit. Oh, there you go. It's on it to the right.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
There it is.
Just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Wow. Yeah, I was wondering if the Martians are double masked. Well, that's a pretty clear image. Man, that lot in Hollywood is pretty good, isn't it?
It's amazing.
Blake likes it. Cool breath. Isn't this really cool? Really, really cool. I swear Jesus is fake.
For Steve. Stand by for Steve.
Well, the primary problem with Mars Victoria is that Mars' core was too small and it cooled off too quickly, and so it lost its atmosphere because it didn't have a protective magnetic shield, and its atmosphere was sheared off by the solar radiation, the solar wind, and that's what happened. Look at that. It looks suspiciously like the Sahel. Did anybody see a lander somewhere in Niger or Mali today? Yes, we're going to see a video, Tony. We're hanging around for that. Welcome, Tony Nagy, in from Alberta, where they lock up Christian pastors.
Our second image.
There you go,
is in.
second one.
Okay, these we have a camera in the front and rear of the
Whoa.
the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. but we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago, just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing.
We even know where we landed.
We figured it out. This is a sign. NASA works. NASA works. And when we put our arms together, and our hands together, and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together.
Not on the budget that Barack Obama gives you.
Make success happen.
Ants is pretty happy about this. I'm with you, Ants. It's pretty cool, man. What a species can accomplish.
Joining us now is the acting administrator of NASA, Steve Jurisic. Steve, welcome and congratulations.
Pretty cool for him.
Hey, thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing. To have Perseverance join Curiosity on Mars, and what just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission. But if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, set, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Set, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us properties, size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions or even as like a launching point?
Yep, oxygen.
Great question, Landon. Actually, we have an experiment called the Mars
Moxie.
Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2. And that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith. And then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes, hi Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks.
Wow.
So it'll be exciting. And some late nights, but we're also excited, and we can't wait.
No women in science.
Lifestyle, yes.
No women in science.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sophia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
It's actually cute.
Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well,
oh, she. The rover's a she, huh?
Good luck living on Mars time.
Thank you. Should be fun.
No women in science.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
No women in science. Look at this.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
New research.
A few things. I mean, it's the biggest and best rover we've ever sent to Mars. And it can really, do amazing things in terms of, its own scientific exploration of this habitable environment, at Jezero. But, it's also, as you've heard today, it's the first step in Mars sample return. So really, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, a lot of the effort to develop the rover was specifically designed, for that sampling and caching system. It's one of the most complex robotic systems ever made. And, having it down safely means Mars sample return continues right on course, and we are moving forward.
Some likes,
Wonderful.
please.
Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
There's a lot of reasons. I mean, obviously, for places that are far away, like Mars,
Sweating.
and even farther away, like Europa. Right now, robotic exploration is the only way we can make these scientific discoveries and really understand these early habitable environments. In the case of Europa, maybe it's even still habitable. And, we're not ready to go there with astronauts yet, but the robots are ready to go there. And so we always, are forerunners and pathfinders of human exploration. And we start by sending, our eyes and arms there in the form of a robot. And it is just fantastic to be able to do that and to learn from each rover, learn from the science and the engineering and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries. And each one is more exciting than the last.
The future does look exciting. Now, as director of JPL, what would you like to say to those teams?
Something wrong with his eye.
Oh, obviously they have earned it. Let me tell you. I mean, they have worked, for years and years on this mission. And then in the past year, of course, we had the COVID experience. And I want to thank not only the team, but also, all of JPL. A lot of folks had to pitch in here, in terms of making sure our remote telework, our IT systems were good enough to support folks working.
Victoria, yes. Let me address this very quickly because it keeps coming up here because I started it. My sarcasm is because of the nonsense that's been perpetuated on our society for the better part of 2 decades. We have constantly heard that women are not in STEM, science, technology, education, and mathematics, engineering, mathematics. That's a lie. It's an absolute lie. 60% of postgraduate students at institutions across the United States are women. And that has been the case for 2 decades, as was said a moment ago by Joking Atheist. And he's correct. In a matter of a decade, there'll be virtually no men left in these rooms. How is that equality? How does that uplift anybody? Not only is NASA distorting this by running around and only recruiting scientists and engineers from inner cities, they're also lying about the gender. And they're discriminating against tens of millions of Americans based on a lie. And so I'm exposing the lie about STEM, where 60% of the graduates in postgraduate schools, which is the people that get involved in programs like this, are women and have been for 20 years. Just do the math. 100 or 10,000 scientists per year, 6,000 the first year, 6,000 second year makes 12,000, versus 8,000. Then 18,000 versus 12,000. Then 24,000. You get it. All right, 60%, 24,000, just 12. In just 4 years, to be twice as many females in the fields of science, technology, engineering, and mathematics as there are males. But this lie is still being spread. The misandry against men is vile and repulsive. And I'm sick of it. And I've been exposing it for years. There you go. Ingenuity, the first helicopter ever on Mars.
This was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test.
Oh, no women. Mimi Ong.
It's extremely difficult to fly at Mars because the atmosphere is so thin compared to Earth. At Mars, it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is
so
30
cool.
working days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering.
The problem with your point, Gareth, is that these are women running these programs, so clearly there are plenty of women.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it will fly at Mars, and we've tested it in the simulated environment that we can create on Earth.
You're correct, Erica.
It really is time now to...
Best and brightest. Gender doesn't matter, nor does race.
Nothing is a given.
Asian, Indian.
We've done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission.
Sounds like he works in Microsoft.
Exciting, reacting to any surprises we have. We can't wait.
Why are there 2 trolls here? They're entertaining.
What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Yeah, the moon, going back to the moon.
Mimi Ong is the project manager for Ingenuity. She joins us now as
Project
they await
manager,
a chance
woman.
to check out their helicopter in the coming days. Welcome, Mimi.
Thank you, Marina.
Oh my goodness, we've been talking about this for months, Mimi. Did you ever think you'd be here at this point? I mean, what's going on in your head right now?
This is super exciting. You know, we have been working on Mars helicopter for over 6 years, testing and carefully designing it for operation at Mars. So what's going through my mind? Ingenuity Mars helicopter is finally at the destination that it is designed for.
Now that Ingenuity is on Mars, what is the timeline you hope to accomplish as you move forward?
We have a series of major milestones between now and Ingenuity's first flight. So tomorrow we'll turn on the helicopter and its base station to confirm health after experiencing the dynamics through the EDL just now. And the next major milestone will be when the rover deploys the helicopter to the surface. And that marks the first moment that Ingenuity operates on its own in a standalone manner.
Gotta make sure it works first.
That first cold, frigid night of Mars will be a major milestone. We'll execute a series of checkouts, and then we will perform that very important first flight. And if the first flight is successful, we have up to 4 more flights in the 30 Martian days that we have set aside for our flight experiments.
And that's when you finally can breathe, right, Mimi? Now, why is it so important to have that aerial dimension to space exploration?
Oh, the AU. Have fun,
a
Amy.
helicopter flying far ahead of rovers and astronauts in the future can provide high-definition reconnaissance information for the rovers and the astronauts.
Just
before
like
they
the
take long
Army.
journeys. And as importantly, being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Game-changing is right, and we've talked about this a lot. You've mentioned the risk is huge, Mimi, but the reward is high. What will be your greatest reward?
You know, our team started with the question of whether a helicopter can fly at Mars, given the extremely thin environment.
Yep, 1% of Earth's
atmosphere.
atmosphere.
We demonstrated a series of technical steps. We demonstrated lift first, and then we demonstrated lift and the first ever powered control rotorcraft flight in simulated Mars atmospheric density. And then we went on to build the full-up helicopter that can not only fly, but operate and survive autonomously at Mars, all under 1.8 kilograms, about 4 pounds. And each of these major milestones have been a first. And the success at each of these has been so rewarding. And along the ways, the rewards just kept coming. And I have to tell you, at this moment, it's going up exponentially. So after all these tests, analysis, simulations,
Good night, Amy.
and more tests on Earth, our team now gets the chance to test, prove, and learn how it works in the actual environment of Mars.
Yeah, it's
Our
very, it
team
has
can
to be
ask
light
for a bigger
because
reward than
they
that.
can't achieve the lift if it's heavy.
Oh, Mimi, I'm so happy for you and your team. And now we're going to take a question from social media on Instagram for you. At Not Vipudi asks, is the helicopter going to be doing science?
Well, the helicopter Ingenuity is a technology demonstration.
Right.
And
Proof of concept.
We are demonstrating the ability to fly and learning how to fly for the very, very first time.
Yep.
And so this is a technology demonstration and a pathfinder for future larger rotorcraft, future missions that will carry much larger instruments.
Proof of concept,
So
ladies
on
and
this
gentlemen.
mission, we're not doing any science. We're concentrating on engineering data. How did the vehicle perform?
Gravity is less
And
than
as
it
you
is here,
saw,
Leanne.
Bob Belleram in the video before, we will be taking a few color pictures, first ever color pictures from the flying aerial vantage point, but that'll be icing on the cake. For this one, this is all about engineering data and how do we fly compared to all our tests we have done on Earth.
Mimi, so much for your team and the future generations of scientists and engineers to look forward to.
Thank you.
Thank you so much for joining us, Mimi, and good luck to your team with that first test flight.
Thank you so much.
Now we look forward to the Perseverance rover and Ingenuity helicopter beginning their journeys on Mars as their adventures are just about to start. Go Perseverance and go Ingenuity. Back to you, Raquel.
Thanks, Marina. Landing on Mars is never easy, but this team has persevered, and NASA's 5th rover is on the red planet. You can still hear them buzzing in the back right now. And to get the latest updates on Perseverance as it explores Mars, follow @NASA Persevere on Facebook and Twitter. I'd like to thank everyone watching for joining us today. And to the students and teachers tuning in, we hope you learned a lot from today's landing, and thank you for all your questions. We have a news briefing coming up at 2:30 p.m. Pacific Time. That briefing will wrap up the day and include reactions from Perseverance team members. We'll leave you now